This is our Dewberry Street subdivision final design, and we are MSSM engineers.
I'm Katie McCann.
I'm Ken Sheetemeyer. I'm Matt Sharp.
And I'm Connor McManus. Our mentoring company was Dewberry, and our mentors were Skip Noddy and John Keenan.
Our site was located in the town of Davidson in Mecklenburg County, North Carolina. It is 20 miles north of the city of Charlotte. Here's a fly-in to give you a better idea of exactly where the site is located. It is just east of Lake Marvin, which you can see to the left. As previously stated, it is in Davidson, North Carolina, and codes are governed by the town of Davidson and Charlotte-Mecklenburg. The site is 2.8 acres in size, and our design was directed to build 14 single-family lots and a community center on the site. We also had to have detached garages because the lots were so small. The comprehensive plan for Davidson calls for affordable housing. They're planning for a growth of 2,000 to 5,000 households in the next 15 years. Our zoning was village infill, which allows for many different by rights uses, and residential and community facilities were both included in those by rights uses.
Okay, our due diligence revealed that there were existing utilities on Beatty Street to the west of the water main. On Delaware Street south, we have a sanitary sewer line and the water main. Sanitary sewer is in green, the water is in green. And also an existing sanitary sewer and a water main on Magnolia Street to the north. The soil conditions are clay soil type D. There are no wetlands on the site, and our egress was along Delaware Street.
This is our first conceptual layout, and it's really highlighted by the road along the outer edge of the parcel and the public recreational field in the center.
And this is our second layout. It's the one we actually chose to do. And basically, it's a simple layout with a cul-de-sac with all 14 lots around the outside of it and the community center at the entrance. And the reason we chose this was because the amount of road on the first layout was so much that we thought this would cost less.
So for our grading plan, we started by grading the road, and our primary objective was to fit to the natural slopes of the parcel. The road just goes right down the center, and there's a low point in the middle to encourage drainage to a central point. It's 3.25% to this low point, and then 1% back up to the cul-de-sac. We did the geometric highway calculations and found that our stop exit distance was acceptable.
For the existing terrain before development, its slopes are ranging between 2 and 5%, all sloping towards this point right here. And there is also a 5% slope 10 feet away from all building pads. The ditches we graded, we have the east ditch here along the parcel border. This one we graded so that the center is the bottom point because it's the high point on the site right there, and it would save cut and fill costs to have it there into an inlet piping down there. The other two ditches drain towards the detention basin in the northwest corner. This is our pre-development time concentration path. To analyze this, we started with the most hydrologically remote point up in the northeast corner right up here. Analyze flow all the way across to the point of interest on the western side. Using TR55 method, the calculations we found for the 10 and 25-year flows were 4.6 cubic feet per second and 7.3 cubic feet per second. We did 10 and 25-year flows because that's what the Charlotte-Mecklenburg design manual wants you to analyze. Again, using TR55, the post-development flows were found to be 19.4 cubic feet per second and 27 cubic feet per second. This time concentration path is mostly the same until this point, but it enters the inlet in our drainage ditch and goes through piping to this point. Oh, and our 10-year storage we found needed to return flows to pre-development levels was 0.41 acre feet.
One of the main features of our stormwater BMP was rain gardens that would line the street all the way up to the cul-de-sac. And basically the way the rain gardens work is the water will track down the curve of the road, and once it's in the road, it'll enter the rain gardens to a 12-inch curved opening. And once it enters there, it'll percolate through the engineered soil into an underdrain. If the soil becomes too saturated, the rain gardens have a 12-inch storage capacity, and if this capacity is exceeded, it'll overflow into the overflow drain in the basically the reason we chose this is because it was an aesthetically pleasing way to do our stormwater. And this is just more detail of our stormwater infrastructure. The orange lines represent the under drains here and the overflow drains here. The inlets for the rain gardens are represented in the green. And as Connor said before, we have 2 ditches that are going straight into our detention basin. And the east side, we have 2 ditches that go into our inlet on the east side.
This is a map that shows the proposed sewer and water lines. The proposed water lines are shown in blue. We decided to tie into Dewberry Street, right along the southern side of the parcel, and the line runs north through the site. It is a 6-inch main along Dewberry Street, and it ties in as a 6-inch main until the hydrant located in the middle. Computed fire flow is 1080 gallons per minute, and from the hydrant on, we have a 2-inch main. We decided to do a dead-end main because Charlotte-Mecklenburg code stated that when you had fewer than 20 lots, this was an acceptable procedure. There are 3/4-inch laterals stemming from the main to each house pad.
And our sanitary sewer line will tie into Beatty Street up here at manhole 2, which is all existing line, and from here down is going to be our proposed line. The sanitary sewer main is going to be an 8-inch ductile iron pipe with 4-inch laterals. There are going to be 4 new manholes on the site, and we are also going to replace the existing manhole here on Beatty Street, where we tie into the existing line. The average daily flow is 5,600 gallons per day with a design factor of 4%.
Our erosion and sediment control plans adhere to Charlotte-Mecklenburg design manual standards. Our phase 1 plan involved the stormwater channels. These are graded to the specifications of our drainage ditches, so they can be permanently seeded after completion of construction and just left there. We have a construction entrance. This is to prevent sediment transportation off-site by vehicles. And we have a silt fence along the western border, mostly precautionary for any sediment that may get past the drainage ditches or anything like that. For our phase 2 plan, the silt fence will be left in until completion of construction. We also have inlet protection along all the inlets. These are the rain garden inlets, or the road inlets, and the 1 inlet in the east ditch leading to the piping. We also have outlet protection right here, and that is at the outlet from the piping to the sediment basin. This is our sediment basin up in the northwest corner. This has the advantage of eventually being dredged and converted to our detention basin, and it will be graded exactly like the detention basin is planned to.
All right, and throughout this entire design process, we were able to create a cost estimate. It includes all site work, road construction, water, sanitary sewer, stormwater, and ENSC plans. And the total cost of our design project was about $430,000.
Finally, we did a visualization in Google SketchUp. Here's a street view. As you can see, it has all the proposed features that we plan to implement, including the rain gardens in the creekways. It's a little bit tough to see. Here's a view from above. This is just like planned. We have the cul-de-sac in the middle with all the lots and their detached garages on the outside, the community center in the corner with the parking lot. Do you have any questions? Thank you, Phil.
Thanks for the graphics, because I was wondering how you had the buildings. I was wondering if there was a garage and a standalone building, so it's good to see that. With the community center that you have at the front of the site, were there any special design considerations or things you had to worry about as you were putting in the parking lot in the building?
Yeah, we had a size footprint that we needed to accommodate, and we just to that the parking lot, and we had the slopes drain to the road so that water could also be accommodated by the rain gardens.
Was that a requirement of the zoning or of the client?
The community center?
Yeah.
The client.
What was the problem? I missed that? I'm sorry.
How much have you been able to reduce the size of your detention basin through the inclusion of rain gardens?
The rain gardens only held about 1,000.
Yeah.
So it was a small amount, but I think we only did it to the story capacity, which is within this.
John, anything else, please, guys?
my owner would let me do the cul-de-sac, I would power some of their designs, so. Good job.